A linear relationship is when one variable goes up or down at the same amount each time the other variable goes up by one or down. So that kind of sounds like a mouthful, but it's a constant rate of change. When you drive on the highway and you set your cruise control to 65 miles an hour, because we all drive at the speed limit or below, right? If you set it to 65 miles an hour, if you don't change it, you're proceeding at a linear rate. Okay? So to test if something's linear, we can calculate the slope. So you'll want to identify an x and a y variable. And time is almost always considered the x variable. I can't think of any instance where you wouldn't want to. Because the x variable traditionally is the independent variable, the thing that's causing the change in another variable. And so to find a slope, you would subtract two y values by their corresponding x values. That's what the sub 2 and the sub 1 means. So this could be my y2. That means this is my x2. Okay, so I'm going to put 468, 75 in for y2. So that means I'm putting in 25 in for x2. And this can be my y1, or you could pick any other number and it would still work, assuming that this is actually linear. So here's my x1 and y1. And so if I compute that, what I'm computing is something called a slope. That tells us how fast pay is going up based on hours. So I got $93.75. We went up by $93.75 for 5 hours of work. Or if we finish dividing that, that's $18.75 an hour. Let's see if it's linear by checking another set of 2 points. If our pay, which it should be if we're being paid dollars per hour, if our pay is linear, should get the same slope. So let's pick 2 new points. Let's do $562.50 for my y2. That means x2 is 30. Got to keep those paired up. And I'll use 468.75 again. As long as it's a different combination, we should be all set. So 562.5 subtracted by 468.75, divide that by 5. We got the same thing. So it looks like it's linear. We're going up by $18.75 for every 1 hour, because our dollars is our y variable, hours is our x variable. So that's our slope. That is the slope that they're looking for, $18.75 an hour. Okay, so if you were to do that, you got $18.75 for the first one. If you got $20 for the second one, you would say this is not quite linear. Maybe it's close, but not quite. And another way to check that is to quickly make a scatter plot. Let's say this is 20, 25, 30, 35. Oh, let's see. So let's start at 300, 400, 500. It's a little too big. 400, 500, 600, 700 would be up here. So $20, 375 would be about here, because that's 400 right there. 25 hours, I think I said $20, but 20 hours there. 25 hours, 468. That's a dot somewhere up here on the y-axis. 30, 562. Look, the dots are making a straight line. 35, 652. It's roughly around here. So that means it's linear if it makes a straight line. You don't have to do both. Once you're sure it's linear by calculating the slope, you're done. You can just say it's linear. Okay, so we can do the same thing here. Let's calculate the slope. So 300 is going to be my y2, 150 is going to be my y1, so that means x2 has to be 52, x1 has to be 24. So if you find the slope between those 2 points, that'll tell you how many dollars you're getting per foot for these first two. So you got 150 up top, 28 on bottom. If you divide those two, 5.35. So you're getting about $5.35 per foot with those first two amounts. Now let's just jump ahead. It's just to prove that you can use any pair as long as they're different, as long as you check 2 different pairs. So I'll just do 350 and 150. If it's linear, I should get $5.35. So I'm using this one and this one. So the first one I did was the bottom one, so this one has to be the top one. So if I do that in my calculator, 350 minus 150, and then the bottom is going to be 46. So that's $4. It's $4.34 per foot. Those are not linear. Okay? Because when I use two different points, I got two different slopes. So they're not giving us a consistent amount per foot at this lumber mill. And you could graph that too, and you'd probably see a graph that looks something like this. Maybe it slows down as the number of feet goes up. Not linear because it's not a straight line.